Hello, welcome to Biology 3 again. Last week we finished talking about atom molecules, ionic bond, covalent bond, hydrogen bond, water properties, acid base, and so on. So we finished the general chemistry part. This week we will start the basic organic chemistry. We'll talk about the differences between organic and inorganic molecules. We'll also talk about the basic structure of organic compounds, the differences between polymer and monomers, and most importantly, we'll talk about dehydration and hydrolysis. So, what's the differences between organic and inorganic compounds? For inorganic compounds, they are mostly non-living matters. For example, water and sodium chloride that we covered last time, they are inorganic compounds. Generally, inorganic compounds, they are small and simple, just like water and sodium chloride. And because they are small and simple, they do not have so many bonds. Remember I mentioned that covalent bonds stores energy. Since they have a very simple structure, they do not contain so many covalent bonds, then they are low in energy. When they don't have so many covalent bonds, then they also do not store so many energies. And they are usually solids or gases. Here are some of the examples of inorganic compounds. For example, copper hydroxide, calcium carbonate. Calcium carbonate is the chalk. It's the chalk, yeah. And then potassium chromate, and then cobalt chloride. And then if you study geology, then you will know that there are lots of minerals that we can find from nature. They are also inorganic compounds. For example, quartz. We can find quartz in our watch, in many watches and clocks, and it is an inorganic compound. Calcite. Calcite is a natural occurring calcium. Well, I don't know too many of these. Sorry about that. Okay. What about organic compounds? They are, we call them molecule of life, meaning that all living organisms require or need organic molecules. Or all living organism has organic molecules. How do we define organic? An organic molecule must have both carbon and hydrogen atoms. In the past, before I started to learn biology, I naively thought that organic molecules, or they only have carbon. As long as they have carbon, then it's organic. No, the strict scientific definition for organic molecules or organic compounds is that they must contain carbon and hydrogen. In general, organic compounds, they are relatively larger and also more complex when you compare to inorganic compounds. They generally has more covalent bonds in the molecules, in the structure. As I mentioned before, covalent bond stores energy. The more covalent bond an organic compound contains, the higher energy it can store. That's why it says in here high in energy. And many of them they are in liquid forms. Well, for obvious reason, as we learned from last time, approximately 60% of our body is water, and approximately 80% of any cell in our body is also approximately 80% of a cell is also water. Since our body and our cells contains mostly water, so most of the organic molecules they are also in a liquid state. So allotroph, what is allotroph? Allotroph, there are different crystalline forms of a chemical element. What does it mean? Let's take a look at the example of carbon. So carbon can exist as a charcoal that we use for barbecue, and also it can exist as graphite. Graphite can be the graphite that we use for drawing or sketching, and then it can also exist as diamond. Well, that is the most expensive among the three forms of allotrophs. When they exist in different form, they have different structure. You can see it here. They exist in different structure in here. So different structure of carbon, they will form different they will have different crystalline form. For diamond, graphite, and charcoal, they all have different types of structure here. So organic matter and material, as you can see in this picture, all of these here are organic. Plants is organic because, and then carbon. Well, all these are based on carbon, but this one is not organic. It may or may not be organic. Depends if it has a hydrogen atom. Animals is like human beings. Okay, textiles. Textile, they are from plants, of course. Food, they are from animal or from plants. Combustion fuel, and these are from fossil. They are from the dead body of ancient animal, primitive animal. That's why they are also organic. Plastics and synthetics, they also come from fossil fuel. And then dyes, some dyes they are organic, but some dyes they are inorganic, they're chemical dyes. And then pharmaceuticals. Most of the pharmaceuticals they are derived from a plant extract or animal extract, but not all. So dyes and pharmaceutical they are not all organic. So remember we talked about the differences between organic and inorganic compounds a few slides before. Do you still remember? So here is the exercise I want you to do. You may take out a piece of paper and try to and write down the differences between inorganic and organic compounds. You may pause the video at this point and try to complete this table. So here is the answer. Well, inorganic compounds, they are mainly non-living matter, but organic is mostly living matter. Inorganic, they do not contain carbon and hydrogen. Organic, they must contain carbon and hydrogen. Inorganic, usually they are small and simple. Organic compounds, they are usually larger and more complicated. Inorganic compounds, they are mostly in solid and gaseous state. Organic compounds, they are mostly in liquid form. So since we said that organic compounds usually contains carbon, let's take a look at the carbon atom. Carbon atom always form 4 covalent bonds. when carbon atom form 4 covalent bond with the same with, let's say, hydrogen, then it will become nonpolar. In here, what it says nonpolar, it depends on what atom or functional group it attached to. If you have hydrogen here and a hydrogen here and a hydrogen here and a hydrogen here, and this is a carbon, then it will be nonpolar. However, if you have a let's say if you have a let's say if you have a large benzene ring here. We will talk about benzene later in the slides. And let's say we have also a hydrogen here. Let's give a hydrogen back here. Then this molecule, this compound will not be nonpolar, because the benzene ring here will attract a lot of electrons. So it will act like a bully and pull all the electrons to himself, so that it will be a slightly negative in here. Remember the delta negative. And the other hydrogen atom will become slightly positive. So it really depends on what group or what kind of atom or what kind of functional group attached to carbon. If the 4 atom or 4 functional group they're identical, then it will be nonpolar. In other words, if all 4 they are attached to, let's say, a benzene ring, all 4 will be benzene ring, then this compound will be nonpolar. And here are some examples of the a carbon that forms a 4 nonpolar and covalent bond. So these are the examples of nonpolar and covalent bond. I gave you an exceptional case.